you're going to see a mock interview that we put together with Gareth Gibbs, who really did come here for an interview 4 years ago. I have his papers in front of me, and he's written a good personal statement. His school says wonderful things about him, and at the back we can see that he's got some A stars at GCSE, some A's and a B, and he's doing 4 A levels in maths, physics, computing and history. So all in all, before I see him, on paper he looks like a pretty strong candidate, and as you can imagine, that as we did actually take him, he was a strong candidate. The computer science interviews are reasonably well structured. I have a little script which we run through with things that we must say to each candidate, and then the questions, so that we can be sure that we're asking everybody who comes for interview pretty much the same questions, so that everybody gets as fair a deal as possible. Hello, you must be Gareth Gibbs.
Hi.
I'm Neil Dodgson.
Hi.
Can I sit down?
Thank you.
Okay, I'm Neil Dodgson. I'm the Director of Studies in Computer Science here at Emmanuel, and I'm also a lecturer in the Computer Science department, so I do both jobs. Now, we use a variety of things to determine who we can offer the places to. They are your and your school's written statements, which I've read, your exam results, obviously, the little test that you took earlier today, which I hope went okay.
Yeah, I think it was all right.
Okay, and of course the 2 interviews. So the interview is just part of the whole process.
Okay.
Right, the interview is about 20 minutes long, and I'll be asking you questions on a variety of things related to computer science, and at the end you'll get the chance to ask me anything that is unclear, or you can tell me anything that you think is important that we haven't covered.
Excellent. Okay.
Okay, so to start off, let's ask the obvious question. Why do you want to do computer science at university?
Ooh, I really enjoy working with computers.
Mm-hmm.
I've had some experience both at school, at A-level and beforehand, working with computers, and I love the way that with computers there is so much potential. What you can do is potentially limitless. You're just limited by what you can think of and imagine. As well as that, computers are in use all over the world in every different field of study. So working in computer science then gives you an open door into any other potential field. So I find that really exciting, and really looking forward to what I could do with that later on in life as well.
Good. In your personal statement, you said that you have a good understanding of computing principles. So where do you think you got that good understanding of computing principles?
Okay. I see computing really as almost like an extension of maths, I suppose. It's very logical, and I really enjoy the lateral thinking and the logical content. I feel I've gained some experience in that from the computing that I've done at school, from the maths I've done. I've also done a bit of work in my spare time, just kind of playing around with computers. Mm-hmm. And so I guess just experience of that.
Okay, what's the most serious piece of computer programming you've done so far?
Well, mostly just playing around, to be honest. I've not done anything that serious. It's more just bored during the holiday and see what I can throw together.
Okay, I think that ends the first part of the interview, and what we'll go on to now is doing some problem solving. I'm going to give you a couple of maths problems to have a look at. Now, the reason we do this is because your exam results tell us a lot about how good you are at solving problems, but they tell us nothing about your personal style and how you do these things. Okay. So I'll give you some problems which we probably won't get through to the end of, and you'll probably just be getting the hang of it when I tell you to stop, which can be very frustrating, so be ready for that. But what I want you to do is talk me through what you're doing, rather than just do it.
Okay.
We'll start with a simple mathematical question. Can you draw me the graph of sine x over x? Got some paper.
Right. Okay. What I'd start with is just drawing a graph of x. So that will be something like that.
Yeah.
Then graph of sine x is going to be, Okay, the scale is completely out on this.
It's all right. It's just a sketch.
So what we're going to do is if we're doing sine of x over x, then as you move along the x-axis, the sine wave is going to scale down, so it's going to be getting smaller as x increases, and then that'll be mirrored on the reverse side. So
why is it mirrored?
Sorry, no, I mean not mirrored, it will be the same, as in it'll be, you'll have a large negative number. So over here you'd have sine x would be negative, and x would be negative, so that would just be smaller than over there.
So would it be mirrored in this axis, or would it be rotated by 180 degrees around the origin? I've got another problem here.
Okay.
We have, if we look at this little test here, question 2, you have a donkey tethered to the perimeter of 3 fields in turn. So one field is square, one's an equilateral triangle, and the other's a circle. Now each field has an area which we'll call A, and we attach the tether to a corner of the field, if there is a corner.
Okay.
So what I want you to do is determine the length of the tether in each case so that the donkey can graze an area of A over 2.
Okay.
So is there anything about that you don't understand?
No, I think that's okay.
Okay. So how would you get going?
I think I'll start with the square on this one. So we have a square.
Yeah.
And so we're going to have a rope in one corner. So if we have the donkey attached there, so the donkey will be able to graze in a quarter of a circle part of the field, and then so we're trying to work out the length of that rope. Let's call it x. So that is a over 2. So we want a over 2 here, and then a over 2 on the inside.
Yeah.
Okay, let's call each edge, let's just call it B for now. So we have 4 edges, so the total perimeter then is just going to be 4B. In which case the area of the square is going to be B squared. So we want the area the donkey's grazing in to be B squared over 2.
Okay, so what's the area the donkey's grazing in?
The donkey, okay, the area of the circle is worked out, so okay, circle equals pi r squared. But here we only need to be dealing with a quarter of that, so donkey is grazing in pi r squared over 4, and if we then equate that to b squared over 2, we can cancel.
Okay, and what is b squared? Given that there's no b in the question.
B squared is going to be a over, sorry, yeah, b squared is a, that's what we have, so we have pi r squared equals 2a.
Okay, I'm sure you can do the rest from GCSE maths.
Okay.
I believe that you can do
yes.
it from GCSE maths. What happens if you then try the same trick for an equilateral triangle?
Right. Equilateral triangle. Donkey in here, and we now have that. Okay, for an equilateral triangle, the difference is going to be the portion of the semicircle that we're using. In an equilateral triangle, the angles are all going to be 60 degrees, so that it all fits, and that is going to be 1/6 of the circle.
Yep.
So the only difference then will be if we can leave a in over here, and so we'll just need to divide that then by 6.
Okay, so pi r squared over 6.
Yeah, so pi r squared over 6 equals, that's going to be that area, which is going to be a over 2 again. A over 2.
Okay, and again you can do the maths.
Okay.
Now what happens if you try to do this for a circle? I have a circular field.
Okay, so if we have a circular field. Now, if we tether there, okay, now, right, that makes it a bit more difficult.
Why is it more difficult?
Because you need to be careful what portion of the circle it is that you're using. It's no longer quite so straightforward dividing it by 4 or divided by 6. So what we have now I'm not sure where to go on this.
Okay, how would you calculate the area of this shape here? What would you need to do?
Okay, for that you could start by getting the area of the whole circle, which would be that one.
Yep.
So I think we called that R area. So the total area of that is going to be pi r squared.
So how are you going to find the area where the two circles intersect?
Let's have a look at the difference. Shape from there.
So what are you thinking of trying to do here?
I'm trying to work out, trying to think what patterns we've got here, how you can work out what portion you're losing of this circle over here from that one over there.
Well, I think I'm going to stop you there because what you really need to know here is that this takes 2 pages of algebra to solve this one. The other 2 are easy, but this one's really hard. So yes, maybe in half an hour you could get there, but we don't have half an hour.
Okay, that's good.
Okay, we'll leave the maths now.
Okay.
And go on to more general issues about computing and its effect on society. So you can buy almost anything over the internet these days. But what sort of things actually do you think it makes sense to sell over the internet? What are you going to make a profit from selling over the internet?
Okay. The advantage of the internet for people buying and selling things is going to be the number of people that you can sell to. I guess if you have a website, then you've got potentially a lot more customers than if you're on a shop around on the high streets. So it makes sense to be selling things that can really make use of the fact that you've got so many more customers. But at the same time, you have to recognise that you're now separated from them. So whereas on the high street you can possibly sell a service, such as someone brings in a jacket to be dry cleaned, that will be a lot more difficult to do on the internet because it requires people to be meeting up together. So the internet, I would say, is more suitable for things which are standardized. So everyone wants the same MP3 player, so it's very easy to just ship out lots and lots of those to whoever comes onto your website to order those. Okay.
So let's move on to one last question.
Okay.
Information technology, computers, allow organisations to collect and store an enormous amount of information on each one of us, and then to copy this information from one organisation to another and to sell it on. What impacts do you think this capability has on people's privacy?
Okay. I think the privacy information is very important. If information can fall into the wrong hands, then there's a lot of potential for damage to be caused. So things like the Data Protection Act are important for making sure that companies and countries don't just send information to anyone who wants it. So for example, credit card information which may be stored by one company should really be kept safe with them.
Why? What's wrong with selling this information on?
Well,
why can't we have a free market in information?
Because information has power over people. So if you have information about a person's personal details, then on something like the internet, it would probably be quite easy to impersonate that person, and so you could pretend to be one person because you have information that is private to them.
I think that's good. Okay, well that's the end to my questions. So just to finish off, do you have any questions for me, or is there anything else that you'd like to tell me that we haven't covered?
Okay. Yeah, no, there is one question.
Yeah.
I, at the moment, am doing 4 A-levels, and that includes history. Would it be better from my application point of view to carry on working at all of those, or is it better to drop what I'm doing in history and then to focus more on the other subjects?
That very much depends on you and whether you feel you're overloaded.
Okay.
If you really feel you're not coping with 4 A-levels and the amount of workload, then you probably need to go back to your school and discuss that with the relevant people there. But if you're coping fine, then I definitely keep the history going.
Okay.
Because you're doing maths, physics and computing. Great, fine, they're obviously relevant. History teaches you other things as well, a different way of thinking and the ability to write things coherently. And in computing, there's actually quite a lot of need to be able to write things down coherently so that other people can understand them and to formulate arguments verbally as well as mathematically. So as long as you can cope and you're happy with the workload, definitely keep doing all 4.
Okay, yeah. Thanks.
Okay, is there anything else?
No, I think that's everything. Thank you very much.
Okay, thank you very much for coming.
Okay.
I'll show you out.
Thank you very much.
So now you've seen the interviews, you'll see that Gareth was a bit nervous. He answered many of the verbal questions pretty well, actually. You've seen he ummed a lot, he thought a lot. That's fine in an interview. It does help if you are prepared for the obvious questions such as why do you want to do computer science in this case. But a lot of the other stuff, you'll get something thrown at you that you may never have thought about, and it's fine to just stop and think. And it's fine to get it wrong. The interviewer will ask you follow-up questions, and even if you're doing really well, you'll probably find you get thrown follow-up questions. So at some point, you run out of steam, and that's fine too. In terms of the maths, you'll see he had some problems. If you sit down and try to do those problems yourself, you'll find that there are some things where he went a bit off track. But at an interview, when you haven't had any time to see it before and it's completely cold, going wrong's fine. If you go really badly off track, the interviewer will guide you back or throw in ideas. With regard to the maths, you saw that Gareth occasionally went off and did the wrong thing. There was no need, for example, to know how long the side of a square was. But in an interview situation where you've never seen the problem before, you're not going to know that. And we really are looking to see how you work out problems, how you try different ideas, whether you follow the hints that we give you verbally. If you get really stuck, we'll give you big hints to get you back on track. Some of these problems, like the circle problem, really are very, very hard. If you try to do the circle problem yourself, like I've done, you'll probably find it takes half an hour or an hour, and it's really quite hard to work out which way the solution should go and what's the best thing to do. So we are giving you questions that are hard, that will test you well beyond what you've learnt, but that's the only fair thing to do, because if we gave you questions you could answer no problem, then everybody could do that and we'd learn absolutely nothing.